Okay, so in this cloud question session, we'll be covering multi-cloud network architectures for database migration to OCI. We'll see that it's a topic that is quite important and also quite complex as well. So here in this session together with me, we have Marcus Doeringer, who is a data modernized specialist, Emiel Ramakers, who is a multi-cloud specialist in my team. He will be helping us in the Q&A, and of course he helped us preparing all the session. And well, then finally me, which I'm also a multi-cloud specialist. As a multi-cloud specialist, pretty much what we do is we cover all multi-cloud products that we have and multi-cloud scenarios that customers can have. So just as part of this session, we'll be covering three main points. The first point will be just an overview of OCI multi-cloud offering. By the way, I saw in the Q&A, now in the poll, that some of you are not familiar with this, so it's just an overview of what we think about multi-cloud and what we offer about multi-cloud. Then Marcus will cover the database migration options. And finally, we'll see how all this fits together, how multi-cloud and database migration fits all together, and we'll present some of the common architectures and network architectures that we have found, Okay, so let's start. Okay, so first start with OCI multi-cloud. Okay, so it is important to understand how multi-cloud fits in Oracle. So basically, multi-cloud is part of OCI distributed cloud strategy. So the idea behind this is that we want to meet the customers where they actually want to run their workloads. And this includes hybrid cloud. In hybrid cloud, we have, well, the key product, Oracle Exadata Cloud at Customer. We have also some new products like the Compute at Customer. Then there is the dedicated cloud, just a cloud for the customers running the exact same service that we have in our public cloud. That leads to public cloud, which are just all of our OCI cloud service available in different locations. And finally, the target of this, well, one of the targets of this scenario is multi-cloud. So in multi-cloud, the idea that we have behind Oracle is to simplify the multi-cloud deployment for customers. And we do this by reducing the complexity, lowering the cost, and shortening the implementation times, okay? In OCI, now we actually have some products that support this offering. The key ones are the OCI Azure Interconnect, and the new one that has just been released, which is quite cool, is the Oracle Database at Azure, okay? So these are just some of the key products that we'll cover during this session, okay? Okay, so multi-cloud is much more than connectivity, or of course, connectivity is an important part. And here is where we want to explain which are the options that we offer for connecting different clouds. So for example, how you can connect OCI to AWS and GCP, for example. You can use one of our Fast Connect partners. Fast Connect is the private and dedicated connection that we have to reach on-prem data center or other clouds. So pretty much you can use one of these partners that we offer for establishing this private connectivity between the two clouds. The other option, of course, is a VPN. It's the simplest, probably the simplest way, the fastest way, but at the end it uses the internet as underneath. So from a connectivity point of view, this is like the traditional offering that we have, Fast Connect partners and VPN. And then just as I was mentioning with Azure, we have a partnership, an important partnership. And as part of this partnership, we offer the Azure Interconnect, which is a seamless connection between the two clouds, a direct connection between OCI and Azure. And finally is the new product that we just released. It was announced on September and it's now in GA with the ExaDVD product in the Azure regions. More regions will be coming. And basically this product, what it does is something really cool, and is that we offer the Oracle database services on OCI, but located in Microsoft Azure data centers. Okay, so this simplifies the integration with Azure application, and of course, it provides the best latency possible because the Exadata, as it is shown here in this picture, is actually installed physically in the Microsoft data center, and of course, then there is some integration that enables this for Azure customers to use this service. Okay, so from a multi-cloud, this is the overview. So Marcus, you can take over and continue with the database migration part.
Okay, thanks, Ricardo. Let me just share my screen. Okay, so before we actually jump into the multi-cloud architectures, let's first have a look at the database migration to OCI. And to migrate a database to OCI, there are different tools and methods available, and that's also true for a multi-cloud setup. So you're probably familiar with some of these tools and have heard them before, like Data Guard, Data Pump, or Recovery Manager. And now, which method or tool should be used depends on some parameters like the platform and the version of the source database, the database size, maximum downtime, and so on. But before we talk about a specific migration tool, we first need to understand the different migration types that we have. And one of the key aspects here is logical versus physical migration. So, and this is really important to understand the difference between these two migration types. Maybe let's step back from the database for now. And let's say we have a text document, and this is for physical migration now. And we have the text document on a hard disk, and we want to migrate that text document to another hard disk. So what we can do is we can just copy the file over to the target hard disk, and that's a physical migration. So we blockwise copy the text document to the new hard disk, and we basically end up with the same document on the target. Whereas in a logical migration, again, we have our text document here. What we do now is we create a new document on the new hard disk. And you see this also has a new name. It also has a different extension. And then we just copy the lines that we want to transfer to the new document. And we basically copy and paste the lines into this new document. That's a logical migration. So we create a new document, we bring out the data, and then we insert the data into this new document. And the same applies to databases. So in this case, we have a database. It's a 12.2 database running on Linux. And a database has data files where the data is physically stored on disk. And in a physical migration, we basically just copy the data files, or we can use a tool like Recovery Manager to backup and restore the files. And then we end up on the target with more or less the same database. Again, we have a Linux system here, 12.2, and that's the physical migration. The logical migration, again, we have our database, and this time we create a new database. It's an autonomous database in OCI, and you see it all, we have a different version. This is a 19C version. And what we then do is we export the data and we import the data into the already existing autonomous database. Now, the big question is always, what is better? Should we go with a physical migration or with a logical migration? And typically, we recommend physical migration if it's possible, because probably it's a little bit easier. You just copy the database as is, and you end up with the same database on the target system. But depending on the requirements, sometimes you also need to go with a logical migration. For example, if you want to transform the data, if you want to convert from lob files to secure files, you want to migrate to big file table spaces, to PDBs, to higher Oracle versions, or you have a different endian type on the source system or things like that. So then that's something where you may want to choose a logical migration. Now, one thing that also defines if we can go with a physical or logical migration is the target database service that we are using in OCI. So if you are migrating to a base or Exadata cloud service, you can use a logical or a physical migration. But if you're migrating to an autonomous cloud service, you only can use logical migration. And the reason for that is the way the service autonomous database is built. We don't have access to the underlying operating system. We don't have access to the container database. So we can't use tools like Recovery Manager to simply copy over data files to the operating system and spin up a database. So if the target is an autonomous database, we need to go with a logical migration. And then, of course, we also need to choose a migration tool that supports logical migration. Now, when it comes to migrating to OCI, the tools we recommend is zero downtime migration, and I will tell you more about that in a minute, and OCI database migration. OCI database migration is more or less the native cloud service to zero downtime migration. So it's a managed zero downtime migration service. The big difference between these two is zero downtime migration can handle logical and physical migration, whereas OCI database migration service only can handle logical migration. And in today's session, we will focus on zero downtime migration. But before we come to that, there are also different other migration types where we can classify a migration into. And we already have learned what a logical migration is and what a physical migration is. And then we also have offline migration and online migration. And of course, this depends on the maximum downtime that we have for the migration. So in an offline migration, we basically need to stop the application, then we do our migration, and then we can start the application again. And this is a one-time copy of the database. Whereas in an online migration, we try to keep the downtime as minimal as possible. So basically, we have an initial copy of the database, the application is still online, and then we capture the sources on the target and replay them on the source system. We capture the changes on the source system, we replay them on the target and try to keep them in sync. And then during a short maintenance window, we basically switch over to the new database. And finally, we also have the direct connection and indirect connection to specify if we have connect to the source and database and target database. Okay, let's have a look now at zero downtime migration. I already said this is the recommended way to migrate a database to OCI. What is ZDM? It's software you can download from oracle.com, and you need to install ZDM on a Linux VM or a Linux server. And ZDM basically is an orchestration tool that automates and coordinates all the migration actions and leverages the tools, existing migration tools. That's really important to understand. Zero downtime migration is not a new technology to migrate databases. So ZDM really leverages existing technology like Recovery Manager or Data Bump, and it really is an orchestration tool. So instead of writing your own scripts or having a text file with all the commands that you need to execute during a migration, this is the orchestration tool that executes the migration completely end to end. And the way it's done is we have a response file as input for ZDM, where we can basically specify all the parameters for a migration. Important also, ZDM itself is free. So the software, there is no license for that. You can use it free when you migrate to OCI. The only costs that you may have are related to if you need additional storage, where you need to store backups, RMAN backups or data bump exports. And of course, you need to provide a VM to install ZDM, but the software itself is completely free. So how does a migration workflow look like in zero downtime migration? And on the left side here, you see the source databases. We are supporting Standard Edition, Enterprise Edition, starting from 11.204, that's the minimum release, up to 21C. And we support platforms like Linux, Spark Solaris, and also AIX. And important for today, of course, we also support third-party clouds, and also we directly support Amazon RDS. As targets, we of course support all OCI cloud services like Exadatabase, Autonomous, and also the new service Database at Asia that Ricardo already mentioned. So the workflow itself, we also have built in some pre-migration checks into ZDM. So for example, if you're migrating to an autonomous database and your source database has a data type that is not supported in Autonomous, then we will give you also a warning for that before you can even start a migration. And then what you see here, we have the three phases: the initial data transfer, the ongoing synchronization, and the switchover. And the synchronization and switchover part, we already learned that we only need that for the online migration. For offline, we only have the initial data transfer. And when we do a physical migration, ZDM uses RMAN backup and restore to create the standby database or the target database. And in a logical migration, we use data bump to create the target database. And you see, we also support different locations. For example, we support NFS, object storage. For logical migration, we also support AWS S3. This is used if your source database is running on Amazon RDS and you want to migrate to OCI. We can also directly use AWS S3 as transfer medium. And then if we're doing an online migration, for the synchronization part, in the physical migration, we are using data guard to keep the source and target in sync. And for a logical migration, we use Oracle Golden Gate for that. And then in both methods, we finally have the switch over to the target system. So how does the architecture now look like when we migrate with ZDM, and what connections do we need to migrate the database? And what you see here is, this is a physical offline migration. On the left side, we have our source data center. This could be an on-premises data center, but it could also be a third-party cloud like Azure or AWS, where we have the source database running. On the right side, we have our OCI with our cloud services, target cloud services. And what you see here is the ZDM host. I already told you we need to download the ZDM software and we need to install it on a Linux VM. In that case, we have the ZDM host running in the source data center, but it's also possible to have it running in the target data center in OCI. So you can also spin up a VM there and install ZDM in OCI. And then we need SSH access from the ZDM host to the source database server and also to the target cloud service, because ZDM logs into these systems to execute the migration. Additionally, we need access to the object storage here, because ZDM then runs an RMAN backup and uploads via HTTPS to the object storage. Let's go back one slide here. I told you before, in that example, we are focusing on object storage, but for example, we could also use NFS to store that backup here. And then ZDM logs into the target system and downloads the backup from the object storage and creates the target system. So how does this look like now for a physical online migration? In a physical online, we already learned we need data guard to keep the source and target in sync. And for that, then we additionally need a connection from the source database to the target system and also from the target to the source. Maybe one more information, especially with physical online, it would also be possible to skip that initial load via the object storage here, because if you have a connect from the source to the target or from the target to the source that is needed for the data guard, we can also use RMAN to initiate the standby database directly from the service over that connection. So how does this look like for a logical migration? It's similar. Again, we have our ZDM host that needs to connect to the source and the target system. In that case, you see we have SSH or SQLnet. And this is, for example, if the target system is an autonomous database. We already learned that for autonomous, we need to go with logical migration. We cannot log in with SSH to the autonomous. So in that case, we just need to have a SQLnet connection to the autonomous database. And in one of the latest releases of ZDM, we also introduced no SSH connection to the source database. So we only can log in with SQLnet to the source database. We then need some kind of special configuration on that database. We need to have some certificates available and also some ACLs to basically allow the database to run the data bump export and upload it via HTTPS to the object storage. Again, it could also be NFS here. And then basically we use that data bump file here to create the target database. What is also possible with logical migration, we could skip the object storage part here and we could directly create a database link from the target system to the source database and initiate the target system via that database link. But that we only recommend for smaller databases with a maximum size of 100 gigabytes. And finally, how does this look like for a logical online migration? So we learned we need to have Golden Gate for that to keep the source and the target in sync. So we have the Golden Gate service here running in OCI, and we have an extract process that needs a connection to the source database to capture the changes. And then we have a replicate process that replaces the changes here on the target system. Now that Golden Gate hub here, for that we provide a marketplace image in OCI. So you can simply install that marketplace image. It has already a pre-configured and installed Golden Gate included. And this also includes a free license for 6 months for migrations to OCI. So there's no license needed in such scenarios for Golden Gate. And you also don't need to be a Golden Gate expert or administrator for logical online migrations, because what you see here, the ZDM host also needs to have an HTTPS connection to the Golden Gate hub, because in the end, ZDM logs into the Golden Gate hub and creates these extract and replicate processes. So everything is done out of ZDM. So that was a short overview about database migration to OCI, and I will give back now to Ricardo, who will jump into the multi-cloud architectures.
Okay, thank you, Marcus, for this. So let me start sharing my screen. Okay, so now that we understand how complex it is to migrate databases, let's see how this all fits in a multi-cloud architecture, okay? And here what we will be showing is just some of the common scenarios that we have found with the different customers that are going through this journey, okay? So this is just an example. There are different options, different considerations that needs to be taken. So this is something that we will be covering here. Okay, so let's start by this simple scenario. And in this scenario, a customer is using AWS as their primary cloud, and probably AWS is already connected to their on-prem data center. This connection probably is via direct connect connection. Okay, so at this point, this customer is using AWS for deploying their workloads, for moving their workloads to AWS. But the truth is that most of their critical data is still at their on-prem data center. Okay, so they need to find a way to migrate this data closer to their primary cloud. And by the way, I saw in the poll that this was one of the concerns that still not considering or that there isn't a solution that fits most of the requirements for this. So let's say in this scenario, the customer decides to use OCI for the critical workloads in a multi-cloud architecture. Okay, so we can further explain why, but the customer decided to use OCI for the critical workloads and basically for their data management as a data management cloud. Okay, so what they will need to do first is to connect the two clouds, to connect AWS to OCI. They can do it just as we explained with one of our Fast Connect partner. By the way, these Fast Connect partners are worldwide, and pretty much the only thing that you will need is to deploy a Fast Connect on OCI side, deploy a direct connect in AWS, and then use one of these partners for establishing the connection. Okay. At this point, let's say that the customer is ready for receiving the workloads in this multi-cloud approach. So they can deploy, for example, they can go to a multi-cloud split stack architecture, deploying their Kubernetes or their computing in AWS and their databases in OCI. Okay, and this is fine. The only problem is that the data is still at the on-prem data center and they need to migrate it. Okay, so let's see which options they have. Here we will cover the recommended approach that we recommended from Oracle, which is using ZDM. Okay, so the first thing that the customer will have to do is to deploy ZDM. Well, this was also explained by Marcus. In this case, ZDM is deployed in the on-prem data center. Okay, and the next thing that as Marcus explained, ZDM is the orchestrator. So ZDM, in able to orchestrate this migration, will need connectivity with the source database, with the target database, and in this scenario, with the object storage. Okay, and this is something that ZDM will need. So at this point, probably one of the questions that may arise is what happens from a routing and connectivity point of view. Why? Because the customer, already is connected the on-prem data center to AWS and AWS to OCI. So something common that and a basic idea could be, okay, I will just use this connection from on-prem to AWS and from AWS to OCI to migrate the data. Okay, so will this work? Well, it depends. Okay, so this is what is commonly called a transitive routing scenario, where AWS will act as a transitive cloud. And the problem behind this is that public clouds, AWS, OCI, and most of the public clouds natively block this scenario. So this means that when traffic is going through AWS, it will be blocked. Okay, and basically to unblock this, there are different options. One option is to deploy a routing element in AWS that is capable of managing the routing. Okay, so in this example, it's a firewall, but some other common elements that we see are SD-WAN, NFV devices, or NFV routers. Okay, so now the traffic will be from source. It will go via the direct connect. It will reach the transit gateway. It will go to the firewall, from the firewall to the multi-cloud connection to finally reach OCI. Okay, so the good thing about this is that you're using the connections that you will be using for your application workloads, so you don't need to deploy anything else. The bad thing, or the thing that you need to consider, is that you will be using the same pipes or the same elements that you're using in your production scenario. So if the source database is large, let's say 20 teras, and you're planning to migrate it via your production firewall, you need to be cautious about that, okay? Because it can impact at the end your production, which is always critical, okay? So other option is, of course, to deploy a connection between the on-prem data center and OCI. Okay, so let's say the customer wants to avoid the possible problem of impacting production. What we can say is, okay, so let's just deploy a direct connection between on-prem and the newly cloud OCI. For this, the first option can be a site-to-site VPN, with the downside that it uses the internet as underlay. By using the internet as underlay, basically you are exposed to jitter. You don't have jitter, probably packet loss, and commonly site-to-site VPNs are limited to 1.25 gigs. So you also have a bandwidth restriction. The other thing that you can do is just deploy a fast connect, as you did it between AWS and OCI. You can have a fast connect from OCI to on-prem data center. Some things to consider there is that first, it has a cost. You will need to pay for that, and then it takes time. It usually takes time. Okay. Of course, this depends on the scenario. Maybe you're already using a partner here in AWS, and basically you could just connect OCI to this partner quickly, but it's something that will have to be considered. And lastly, another option which is quite interesting is to use a service that is provided in this case by AWS that is called SiteLink. SiteLink, what it will provide is the connection between two direct connect services that they already have. So in this scenario, the customer has AWS connected via direct connect to on-prem, and also AWS connected to OCI via direct connect. So by enabling SiteLink, this connection will be enabled. Okay, so SiteLink also has a cost. So probably a good approach could be to use SiteLink to enable SiteLink into direct connections only for the migration. And once the migration is completed, then just stop using SiteLink. Okay, so in a brief, for setting up this multi-cloud scenario, the considerations that you need to, and the options that you have from a routing point of view are: the first one, to deploy a routing element in the transitive cloud to permit this. And then the other options are site-to-site VPN, just a fast connect, or native services offered by the cloud provider, in this case, AWS as SiteLink. Okay, so these are the considerations from a routing and connectivity point of view. Then, from a security point of view, is what Marcus explained. ZDM needs connectivity, and some ports will need to be opened. Here in this diagram, what we're showing, what the arrows are showing, is who initiates the connection. So in this case, in physical offline migration, ZDM will initiate SSH connection to the target and to the source database. And then the source database will also initiate a connection to object storage, and the target will also initiate a connection to object storage. So keep in mind that you will need to open all these ports in your firewall security groups, knuckles, and so on. As you can see here, by deploying setVM at the on-prem data center, there is no need to enable any incoming connection to the on-prem in production data center. The only flows that will be needed to be open are in OCI, okay? And of course, in egress from on-prem to OCI. Finally, the last thing that is important to keep in mind here is that since we're using object storage here for storing the data, object storage uses HTTPS. So keep in mind that if you have any proxy, any web proxy that may impact this, well, it is important to keep that in mind. Okay, so these are the main considerations from a networking point of view. This is in physical offline. So now let's go to physical online. Migration from physical online from a networking and connected point of view are the same. You have the same options, but on top of that, you will need SQLnet for basically for using data guard. An important thing about SQLnet is that it requires a connection from source target destination. Okay, in the previous scenario, this connection was not needed. Here, this flow is actually needed from source to target. Okay. Now with logical offline, well, this was also as we can see here, there are minor difference in the ports that we can use, SSH depending on the target, and SQLnet for autonomous, but these are just ports that needs to be open. And again, instead of RMAN, this is just data pump that will be used. Again, just as we explained earlier, setVM orchestrates all this architecture. And finally, online, with online, the key point is that we will need the Golden Gate hub here in OCI to orchestrate this. So with this, in this scenario, what we're covering is a multi-cloud architecture between AWS and OCI, where the database is at on-prem. Okay, so we cover physical offline, physical online, logical offline, and logical online. This scenario is with AWS. What will happen if instead of AWS, this will be Azure? So there are a couple of changes, but it's pretty much the same. In Azure, since we have the interconnect, the Oracle Azure interconnect, instead of using a fast connect partner, then you can just directly use the interconnect. This is way simpler from a deployment point of view, and basically you don't need the partner there. You will have the optimal latency. So here in this connection, you can use the OCI Azure interconnect, and then Azure offers an equivalent to SiteLink, which is called Express Route Global Reach. Okay, and apart from that, is pretty much the same. Okay, well, at least from a multi-cloud point of view. Okay. Okay, so now let's go to the new service. Okay, just as I mentioned, we just released this new product, which is called Oracle Database at Azure. Important things about this product is that the Exadata or the Oracle service is actually in the Azure data center, just as it is depicted here. And this Exadata will have actually an IP in an Azure VNet, so it can seamlessly integrate with any Azure service that you deploy or any Azure application that you want to run. It will be directly there in a VNet, so latency and performance is optimal. Apart from that, this VNet is mirrored in OCI. So what this means is that the exact same configuration from an IP point of view that you deploy in Azure is mirrored in OCI. Basically, this unlocks the possibility of also using OCI services for reaching this Exadata. Okay, as you can see here, there is a red thing that says here OCI network, and this is what basically permits to mirror the configuration between Azure and OCI. An important thing to keep in mind is that this is not an interconnect. This is not connecting the two clouds for using any service. This is just connecting, permitting to have the Exadata in Azure and to mirror to OCI. Okay, that's all that it does. Well, additionally, it helps the service for reaching the object storage and the control plane. But that's it. It's important to understand that from Azure, any service from OCI will be reached. This is not for that. If you want that, then you will need OCI interconnect. Okay. So this is just an intro of Oracle Database at Azure. But now let's go to the scenario that we want to cover. So here, a customer decides, okay, I want to use Oracle Database at Azure. and the customer uses Azure as their primary cloud, and they have an express route connection where they have their source database. Okay, so they have their source database. So from a routing point of view, what will happen in this scenario? Again, we will use setDM. setDM will be deployed in the on-prem data center, and in this scenario, instead of using the OCI object storage, you will use Azure files. One of the points, or one of the reasons behind using Azure files and not object storage, first is because object storage cannot be reached from Azure. Okay, and of course, if it cannot be reached from Azure, it also cannot be reached from on-prem data center. Okay, so now from a networking point of view, this architecture simplifies a lot the transitive routing. Basically, it simplifies it because there is no problem about transitive routing. Here's just a direct connection between the two clouds, and that's it. So if you want to migrate data to Azure, you can just do it over this express route. So we deploy setDM here. setDM, again, orchestrates. We'll need to have all these ports open, but the connection will be via this express route directly to Azure. Okay, so this is in the physical offline scenario. The physical online, it will be the same again with data guard that requires SQLnet. And then again for logical offline. Okay, so this is one of the scenario where when the customer Azure is connected to their on-prem data center via Azure. Okay. The second use case that can come with Oracle database at Azure is when the customer is connected to OCI, or when they decide to connect to OCI. Okay, we will explain a bit why this makes sense. Okay, so again, as I said, the same Exadata DVD that is in Azure can be reached from OCI because basically the IP is mirrored in an OCI subnet and exposed there as an IP. Okay, so it will be seen natively there. Okay, so now when we want to migrate a service, okay, we will have to deploy setDM on the on-prem data center, and then again the connection here is quite simple because it is just a point-to-point connection between on-prem and OCI. Regardless that it's physically in Azure, from a migration point of view, it is seen as a direct connection between the two clouds. So again, here, the problem that we faced in the past with transitive routing, it does not exist because it is just a point-to-point connection. Again, the ExaDVD is physically in Azure, but it has an IP in OCI. So from a multi-cloud perspective, it is just seen as two clouds directly connected. Okay, so again, in physical offline, we will need setDM, and setDM will log the source and target destinations. In this scenario, we can reach object storage, so we can do the migration via object storage. Okay. The other scenario is physical online. Again, the same principles, just adding data guard with SQLnet. Logical offline, again, the same principles, just with using data pump import and export instead of Arman, and SQLnet if depending on the target database, well, in this case, SSH, as we're only supporting ExaDVD at the moment. Some users will come in the future. And finally, one important thing is that with this scenario, you can also use logical online database migration. With logical online, as Marcus explained, you will need the Golden Gate Hub. The Golden Gate Hub can be deployed directly from the OCI marketplace, and there are free licenses for migration. So with this scenario, you can use online database migration using Golden Gate with setDM, migrate via OCI, and at the end, consume your services via Azure. Okay, so this is quite cool. Okay, so this is it for this cloud coaching session. I think it's important to understand that these are just some of the most common scenarios that we're facing. As Marcus said, migration is complex. There are a lot of factors from source database to target database to potential to also consideration depending on the data that you will be open to lose or not. So it is quite complex from a migration point of view, and also from a networking point of view. It is quite complex as you need, as many factors can be there. So here we highlighted one of the key scenarios that we're finding. Okay, so this is all from my side, and now I'm jumping back. Okay, hi. So now we're going to explain the initial steps that you need to take in OCI to onboard a multi-cloud architecture like the ones that we have explained, okay? So for this, what we will need in OCI is to have a DRG, a dynamic routing gateway, and a VCN, okay? Well, and also the fast connect for establishing the multi-cloud connectivity. Okay, as I explained, this is with AWS, and I'm also going to cover the option with Azure. Okay, so let's go now back to the console. So now this is the OCI console. Here are listed all the services that you can use here. So for networking, we'll go to the networking section, and here we will go to the DRG. The DRG is the routing construct that permits all the connectivity within OCI and also in multi-cloud and hybrid deployments. So if you want to create a new one, you just create dynamic routing gateway, and pretty much you just need to assign a name and select the compartment. So I already did this. It is called here DRG FR because it is on the Frankfurt region. So this is quite simple. And then I will go to the VCN. The VCN is the virtual cloud network. I already had one pre-built, so I can click here and select the VCN. Okay, this, as you can see, this VCN is already attached to the DRG, so the VCN needs to be attached basically to permit routing. Okay, so now one important thing that we covered during these sessions are the ports that are needed for migration. Okay, the full list is public, so you can find it here in the official documentation, and here are the port requirements when using ZDM, okay? So they are, in a brief, 22.443 and 5021, okay? At least for physical offline. For logical migration, then you may need something additional. But please be sure to check the official documentation, okay? So now back in OCI, you will have to update the security list to allow this. So as you can see here, let's assume that the cloud has the 10/8 network range. So I'm allowing these ports from ingress. Okay, so this is what you will need to do to allow this connectivity. In OCI, we have security lists, which are on the subnet level. And then we have network security groups, which are on the VNIC level. So in this example, I'm just showing how you can do it on the security list. But if you want to be more specific, then you could do it on the network security group, and then the network security group will be attached to the VNIC. So let's say that it can be a bit more precise, okay, if you want to follow this approach. So basically here you will have to add the routes. So one common thing that customers do is that they permit from the security list, they are a bit more permissive, let's say, and then they are more restrictive on the network security group. Okay. Okay. So this is in regards to DRG and VCN. For the multi-cloud connectivity, if you want to connect to AWS, as we explained, you will need to have a partner. Okay. In the previous cloud coaching session, we actually talk about this. This session, it is already public. It is Automate Your OCI multi-cloud connectivity with Equinix. You can look for it in YouTube. And in that session, you can do all the connection with AWS with Terraform, okay? So fully automated. So if you're interested in this, have a look at it. It's really cool. If you want to do it via the console, so you will have to go to networking again, here to fast connect. And in fast connect, you will need to create a fast connect. And here you will have two options, fast connect partner, if you want to use a partner like Equinix, or direct if you want to do the fiber. So if in fast connect partner, here we'll have two options. The one that we are explaining Equinix, but also you can do it as I just said, with Terraform, you won't need to connect to the console. Or if you want to, for example, connect to Azure, then you can do it from the portal. You select fast connect partner, and as partner, you select Microsoft Azure, okay? So after you select this, you will need to build a private virtual circuit, which is basically a private connection, reaching the customer tenant. Select the DRG, because at the end this will be attached to the DRG, the bandwidth that you need for this, and then just the IP addressing that you will want for the BGP peering. Okay, so in this case, 2 virtual circuits will be created for resiliency, so you will need to provide the IP addressing for this. If you don't know what to use, then here you have some examples. Okay, but it's just 2/30s that you will need to define. To be able to establish the connectivity with Microsoft, with Azure, you will need to add the partner service key. This partner service key, you get it when you create the express route circuit on the Azure side, okay? So after you have all your networking set, you have your DRG, the DRG attached to your VCN, and then you have the security list or the network security groups allowing all the traffic that is needed for SetDM to work. Then the next step will be to create the target database. So for creating the target database, again, you go here to the console, Oracle databases, and here there is the list of all the databases that we have in, or all the Oracle databases. So for example, if you want to deploy an autonomous database, you will go here, create autonomous database, and just select the options based on your requirements, okay? And that's it, okay? So when you create the database, you will just create it on the VCN that it's already deployed, and that's it. You should be ready to start working, okay? So now Marcus is going to explain a bit more things on what to do for the migration tools, okay? Thank you.
Okay, let me share my screen here. Okay, let's have a look now how to get started with SetDM. So for the SetDM part, you can go to oracle.com/go-to/SetDM. And then you directly see the zero downtime migration page on oracle.com here. You also get lots of additional information, also about the migration workflows and the logical and physical migration that we discussed. And here you also have the possibility to download the zero downtime migration software. We already discussed we need a Linux VM where we then can upload the software and we can install that software on the Linux box. What we also highly recommend is, additionally to that download here, we release patch releases for SetDM. There is a support node out there under this patch 33509650. And this basically is the SetDM bundle patch, and you can download it directly from here on my Oracle support. And there is also a README attached. Let's have a look here. And in this README, you again have the prerequisites for the Linux host and the required packages that we need. And it also explains how to install SetDM, and also if you already have a running SetDM installation, how to update the SetDM service. And if you have installed SetDM, then you can start it with the SetDM service start. Let me connect to my server here. And when you have started it, you can check with SetDM service status to see if everything is running. So that means the SetDM software processes are running on that machine now. If you want to find out which version are you using of SetDM, you can run a SetDM CLI -build. And then you see the exact version and also the patch version that you are using. Okay, so when you have installed SetDM, you can go to the SetDM home, RHP, SetDM template folder. And here we provide some templates for logical and for physical migration. So let's have a look, for example, at the physical migration response file. As I've told before, this is the response file where we put in all the parameters to run the migration. And you see there are lots of parameters in here and also a description for all of the parameters. Now, let me switch to here. In that example, I already have created my response file. So I have put in all my parameters. The way you start a migration in SetDM then is via the SetDM CLI migrate command. You say migrate database, and then you basically define what is your response file. And then you also need to provide some parameters. What is the source database? What is the source node? How to connect to the source database. In that case, I'm connecting with the database user with Oracle. And I also need to specify my SSH key here, and the same for the target. And before you can run the actual migration, you need to specify a -eval, which means we are running SetDM in evaluation mode. So we are going through different phases to check if everything is set up correctly. So we are checking, can we connect to the source database? Can we connect to the target database? Is the object storage reachable and things like that? And if the evaluation is successful, we can then run the actual migration, which is basically the same command, but here we just remove the -eval command. And when SetDM runs, you can monitor that the running job with SetDM CLI query job and specify the job ID. So when you run that migrate command, SetDM gives you a job ID. So for every migration that you execute, the number increases. And let's have a look at a job here that I have already started. And we get more information about that job. So when the job was started, we see what is the log file for the job, for how long it ran, and you also see the different phases that SetDM runs through, because we said SetDM really does the end-to-end complete migration of the database. So again, we did validate to see if we can reach the target and the source. Then this is a logical migration. We are doing the data pump export, the upload to the object storage, import. And you see here, in that case, it's a logical online migration, because we also have the golden gate phases here. So SetDM takes care of creating the replicate processes and the extract processes. And what is also special here in that logical online migration, when you run the migration with the migrate database, you can also specify a -pause after, and then a phase that SetDM runs through. So you basically can pause after each of these phases. But when you are doing a logical online migration, you basically want to pause exactly this phase. This is here. And that means at that stage, we are keeping the source and the target in sync. So you can, I don't know, keep SetDM running in that state. And then in the maintenance window, when you actually want to change the application to connect to the new target system, you basically execute a SetDM CLI resume migration command, and then you're running through the final phases here to prepare the switchover and actually switch to the new target database. Now for that, we already discussed also we need a golden gate installation where SetDM can connect to and basically configure these replicate and extract processes. And how you can set that up, you need to go to the OCI console, and then in the navigation menu here, click on Marketplace. And here in the Marketplace, search for Golden Gate. And there is a Marketplace image here available called Oracle Golden Gate for Database Migrations. And that's the one that you need to install. You click on that, and you also see here that it comes with a free license for 6 months when you migrate to OCI. And then you basically just need to specify a compartment. You click on Launch Stack. You can give the stack a name. So in the backend, what we are doing is this is done via Terraform and Oracle Resource Manager. Click on Next here. And then you can specify a few parameters like the host name. You need to specify a network. You need to have a VCN, or you can create a new network for this. Some parameter about the instance. And finally, you also need to specify an SSH key because you need to log into the system. And when you click on deploy, it takes about 5 minutes and you have the Golden Gate instance running. After that, you just can use HTTPS to connect to that Golden Gate instance. when you deploy the VM and you first log in via SSH, you find under the OPC user a file oggcredentials.json. In that file, you find the username and the password when you log in via HTTPS to Golden Gate. And then you can also change the password for that. And that IP address where you have deployed Golden Gate is basically then provided as input for setDM in the parameter file, so setDM can connect to that Golden Gate. So that's how you start the database migration with setDM and Golden Gate.
Okay, thank you, Marcus. So hope you find this session useful. Thank you all. Right. Jumping back to Tom for wrapping up this session.
If we're all good to go, I think I'll close the call and wish you all a great day and look after yourselves. I'll talk to you all soon. See you in the next one.